Hello guys, welcome to another episode of GeeklyEDU. My name is Eddie, and today we will be talking about U substitutions. More specifically, U substitutions in indefinite intervals. So, let's see what this looks like. We know already that there are certain integrals that we can just solve right away. For example, if I have the integral of e to the power of x dx, we know right away this is ex plus c. If I have any sort of polynomial, x to the power of n dx, this is going to be x to the n plus 1 divided by n plus 1 plus c for any n that's not -1. So then if I have x squared, I know right away it's going to be x to the power of 3 over 3, etc. Now, we're going to look at two types of integrals that we can get where we may need an additional tool. Number one is going to be an integral that's very similar to one that we already know how to solve. For instance, let's say that we have the sine of 3x dx. So we know already what the integral of sine of x dx is equal to. Okay, this is the negative cosine of x plus c. But we have this pesky 3 over here that's probably going to change things a little bit. So what we're going to do is, you guessed it, we're going to use a U substitution. And basically what we're going to do is we're going to try to make this integral look more similar to this one. So I'm going to say that 3x is going to be equal to u. And then I'm going to take the derivative of both of those because I'm not going to be dealing with x anymore. I'm going to be dealing with u. So I'm going to change this 3x right here, but I also need to change this dx right here. So this is going to be 3 dx. This is going to be du. Okay? And that's my change of variables, basically. So now I just substitute following this rule that I just created here. So now I'm going to have the sine, and I said that 3x was equal to u, so I'm going to have sine of u. And then dx is going to be du divided by 3. We can take this 1/3 outside, and I realize that now I basically have the same integral I had before. I have sine of something, differential of something, okay? And right away, this is just going to be 1/3 of negative cosine of u plus c. So negative 1/3 cosine u plus c. So I'm almost done here. I solved the integral, but my original integral was not in terms of u, it was in terms of x. So I need to go back. Very simple. Well, I look again at the change of variables that I made before, and I realized that, well, I said u was 3x, so this is going to be negative 1/3 of the cosine of 3x plus c. And that's it. So then a U substitution is this tool that I have that allows me to basically simplify an integral. Let's do another example. Let's say I have 3x plus 7 to the power of 4 dx. So I could actually try to expand this polynomial, and then I'm going to have a bunch of terms, and it's going to be pretty easy to integrate, but it's going to take too long. Okay, so I'm going to have some terms to the power of 4, some terms to the power of 3, power of 2, power of 1. It's too much. So then I realized, well, if I had the integral of x to the power of 4 dx, it would be very nice because that would be x to the power 5 over 5 plus c. So I'm going to do a quick change of variables. So once again, I realize, well, for this integral to look more like this integral, I need to substitute the entire thing that's being raised to the power 4. So I'm going to say that 3x plus 7 is equal to u. But remember, I also need to change the dx. So 3dx on this side, and here du. And that's it. So now I substitute that and see what I get. So I'm going to have the integral of u to the power 4, and then du and a 1/3 over here. And I realize that, oh, I have this very integral once again. So I know that this is going to be 1/3, 1/5 u to the power 5 plus c. It's important to have the constant, guys. Don't forget that. So this is going to be u to the power 5 over 15 plus c. Fantastic. But remember, the integral is solved, but it's in terms of u now. So I need to go back because I need it to be in terms of x, of course. And I look at my little change of variables here, and I see that u is actually equal to 3x plus 7. Therefore, 3x plus 7 to the power of 5 over 15 plus c. And that's it. So then, yes, I could have actually expanded this polynomial and spent 15, 20 minutes just multiplying here and there and solving 10, 12 simpler integrals and eventually get to something similar, but this is way easier. So then, just as a quick summary, a U substitution is basically a little trick that we use to make an integral that looks very similar to one of these integrals that we can just find in a table. We just move things a little bit so that it looks more like it. For example, in the first case, I know the integral of sine of x, and here I have the sine of 3x, very similar. Okay, so I just have sine of something. Now, the something now had a number, so I have to do this little trick to work around that. But, as you can see, it's actually very easy. You just compare the integral that you have with the integral you want to have. And then you say, well, okay, I want to have just a variable inside of the sine. And now I have 3x. I just want to have a letter. So 3x equals u. And u is just the letter that we're going to be using. That's what we call it, U substitutions. But you could have called it A, Y, Z, whatever. Same thing here. I look at this integral and I have something to the power of 4. And I realize that, wow, it would be so cool if I could just have a variable to the power of 4. It would be very easy. Oh, okay. So then I make sure that the whatever is being raised to the power of 4 be equal to this new letter, new variable that I'm calling u. And just like these problems, we can do many more. I'm not going to solve these, but just so you can have them as examples. But I could have the integral of e to the 17x dx. I could have the square root of 2x minus 1 dx. I could have the integral of the cosine of 3x plus 2 dx. And then in every case, we would just do a U substitution. U equals 17x, U equals 2x minus 1, U equals 3x plus 2. then it is very important to always find du as well. Okay, du equals 2dx, du equals 3dx. Basically, just substitute and solve the integrals. So I hope that was clear, guys. If you have any question at all, please leave it in the comments. We'll get back to you as soon as possible. We're posting videos almost every single day about so many topics. So click the like button, subscribe, even maybe turn on the notifications, and I'll see you in the next one. Bye.